Hello, my name is Gavin Walker from the JBS Law Magnet, and I'll be doing free response 2 from 2013 AB1. Question gives us on a certain workday the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by the continuous function g of t, where t is measured in hours between 0 and 10. Selected values of g of t are given in the table below. At the beginning of the workday, t equals 0. The plant has 500 tons of unprocessed gravel. During the hours of operation, 0 and 10, the plant processes gravel at a constant rate of 100 tons per hour. Letter A asks us to find the average rate of change of g of t over the time interval 4 and 6. And show the calculations that led to your answer using correct units and interpret your answer in the context of the problem. So what we're going to do is we're going to set it up like a rock. So we're going to be doing g prime of t equals g of b minus g of a over b minus a. So it's going to be g of 6 minus g of 4 over 6 minus 4. So using the table, we're going to find the values of 6 and 4. So we're going to be finding the values of 6 and 4. So 6 equals 70 and 4 equals 120. So it's going to be 70 minus 120 all over 2. That's going to be equaling negative 50 over 2, which would equal negative 25. Okay? And then so the statement would be okay. The rate at which gravel is being processed between t equals 6 and t equals 4 is decreasing by 25 tons. Okay, now we can move on to B. B states, is the amount of unprocessed gravel at the plant increasing or decreasing at time equals 6? So, how we're gonna... So basically all we're doing is... Alright, hold on a second. Increasing or decreasing at time equals 6. So what we're going to be doing is similar to the previous question, except instead of using 4 and 6, we're going to be using 7 and 4, since those are the surrounding numbers, or those are the given surrounding numbers of in the table, but around 6. So we're going to do the same thing. We're going to skip past the whole thing. So g prime of 6 equals g of 7 minus g of 4 over 7 minus 4. So that will be 50 minus 120 over 3. That will be 70 over 3. Negative 70 over 3. So since it's negative, we know that's decreasing. So we're gonna put in our statement it is decreasing at time equals 6 because g prime of 6 is negative. Okay. So that's done for B. So C. C asks us, based on the mathematical model, is there a time where gravel arrives at the gravel processing plant at a rate of 100 tons per hour? And then it says explain your reasoning. So this is going to be a statement. Statement's going to be, yes, there is a time when the rate is 100 because the function is given as a parabola. Whose domain is, or, wait a second. Not whose domain, whose range. Whose range is 15 less than or equal to g of t, which is less than or equal to 135. Okay, so that's done with that. D. Now, D is asking us, based or assuming that gravel arrives at the plant at a constant rate of 135 tons per hour for the first 4 hours of operation, how much unprocessed gravel is at the plant arrives at the plant during that time interval? So this is relatively simple. All we have to do is multiply 135 times 4, and then we get 540. So 135 times 4 equals 540. So 540 for 540 tons of unprocessed gravel arrives at the plant. Arrives at the plant. Okay, D. So now down to E. So E, what we're going to do, we're going to be doing, so E asks us, using data from the table and the sum of 4 products, approximate the total amount of unprocessed gravel that arrives at the plant during the hours of operation on this workday, and show the calculations that lead to your answer. So for this, we're going to be using, I'm going to be using LRAM. So what we're going to do, you're going to do sigma from 0 to 10, g of t dt equals LRAM equals executed from 0 to 10. So then now we plug in the different functions. So f of 0 times 4. So you do f of 0 times the difference between the number and the next number. Okay? So f of 0 times 4 plus f of 4 times f of 4 times 2 plus f of 6 times 1 plus f of 7 times 3. The reason we don't use 10 is because with LRAM, 10 wouldn't, the last number on the right is not included in the function. So now, afterwards, we plug in and multiply, so that'd be 540 plus 240 plus 70 plus 150. And all of that equals 1,000. So now we write a little statement saying about 1,000 tons of gravel arrive at the plant. Now out down to E, our last one. F. So F states, using your answer from part E, approximate the amount of unprocessed gravel at the end of the workday. So for this, I did RM, since RM might be closer because it would also encompass 10. So we're going to be doing the same thing, similar thing, 0 to 10, G of T dt, approximately RM, executed from 0 to 10, so that would be F of 4 times 4. So why I chose this, because the difference between these two means 4 and then F of 4. So F of 4 plus F of 6 times 2 plus F of 7 times 1 plus F of 10 times 3. And after that we just plug in 480 plus 140 plus 50 plus 375 equals 1,045. So then about 1,045 tons of gravel arrive at the plant. And that's it for free response number 2. Thank you very much.